Statistics is really a branch of mathematics. Although you are probably not a mathematician, you only need statistics as a tool for solving other types of problems. This video is to show how the notation developed by mathematicians can help us solve the formulas for the mean. This lecture will also be helpful for the formulas for the variance and the standard deviation, which are next on our list. Here are the formulas for the population mean and for the sample mean. The population mean, you'll remember, will have mu because it's a Greek letter. So mu, the population mean, is equal to the sum, capital Greek letter sigma, of the x's divided by capital N. The formula for a sample mean is x bar equals the sum of the x's in the sample divided by small n. Now, sigma is a mathematical operator. It tells us to do something. In mathematics, if we want to add, we're told to do so with a plus sign. If we're told to multiply, it's with an x, or sometimes with an asterisk. The sigma notation tells us that we're supposed to add a list of numbers together. And the list is determined by the indexing. So in this case here, we're going to index from I equals 1 to capital N for the population, for small n for the sample. Let's say we have a sample of animals from the local animal shelter, and we're interested in their average age. Take a look at the data. This is what we've gathered, and this is our sample. If we list each value or observation in a column, you can see that we give each one an index number. So here's our table over here. Okay? The first number is number 1, and the second is number 2, and so on the list. So the list might look like this. Purr is animal number 1. Purr is a 9-year-old cat. Toto is animal number 2. Toto is a 1-year-old puppy, and so on. To calculate the mean, we are told by the formula here that we are supposed to add up all of these numbers, the ages in this case, and divide by the sum. That is to say, the 10 animals. So in this case here, here's xi, and we're told to get x1, that's for Purr, x2, that's Toto, and so on until we get to x10, and that's for Dundee. And Dundee is a 9.5-year-old dog. Okay? Now, the indexing is from I equals 1, here's the 1, until we get to the end, which in this case is 10, because there's 10 here. Okay? If we add all those numbers up, that gives us the number on the top. It turns out that that is equal to 78, okay? And then we divide by the number of observations, which is 10. So it turns out that the sample mean is equal to 78 divided by 10, or 7.8 years.